In this video, we're going to talk about solving quadratic equations using the zero product property. So the zero product property is the basic idea that if you multiply two numbers together and the answer is zero, then you know that at least one of those numbers is zero, because the only way to multiply two numbers together and get zero is if one of the numbers is zero. And we write that like this. We say if A times B equals zero, then A equals 0, or B equals 0, or both of them equal 0. So if I have this quadratic equation here in factored form, x plus 5 times x minus 2 equals 0, if x plus 5 is A and x minus 2 is B, right? If A times B equals 0, then either A equals 0 or B equals 0 or both. So if x plus 5 times x minus 2 equals 0, then x plus 5 might equal 0. So I write this equation here. Or x minus 2 might equal 0, or both. And then we could very simply just solve these two separate equations to find the x values that give us our zeros of the quadratic function. So here, x plus 5 equals 0, all I have to do is subtract 5 from both sides. And I get x equals negative 5. And here, x minus 2 equals 0, all I have to do is add 2 to both sides. And I get x equals positive 2. So these are the zeros of this quadratic function. These would be the x-intercepts that you would get if you were to plot this quadratic function on a coordinate plane and see where the parabola intersects the x-axis. It would intersect at negative 5 and positive 2. And that's how we use the zero product property to solve a quadratic equation. All right, so let's take a look at some examples of quadratic functions written in factored form and use the zero product property to find the x-intercepts or zeros of the function. So what we want to do is take this function and write it as an equation set equal to 0. So we're going to say, all right, x minus 15 times x plus 7 equals 0. And so if A times B equals 0, then either A equals 0, so I can write the equation x minus 15 equals 0, or B equals 0, so I can write x plus 7 equals 0, or both. And what we want to do now is just go ahead and solve these very simple one-step equations. So on x minus 15 equals 0, all I have to do is add 15 to both sides. And I get x equals positive 15. And over here, for x plus 7 equals 0, all I have to do is subtract 7 from both sides. And I get x equals negative 7. So these are the x-intercepts or zeros of this quadratic function, 15 and negative 7. And so these would be the solutions of the quadratic equation. Now, if you look very carefully up here, you can see that there's a pattern that emerges. Notice our first binomial is x minus 15, and the answer here is x equals positive 15. Now, why is that? Well, think about, what do I have to add to negative 15 so that I end up with 0? Well, that would be positive 15. And over here, where x plus 7, our solution is x equals negative 7. And again, what would I have to add to positive 7 so that I end up with a 0? Well, that would be negative 7. So a trick that you can use when your binomials have an x that has a coefficient of 1, like these do, is your x-intercepts or your zeros are simply the opposite of these numbers. Here I have a negative 15, and my x-intercept was positive 15. Here I had a positive 7, and my x-intercept was negative 7. So let's go ahead and take a look at this second example, and I encourage you to pause and try it on your own, and then come back and see if you got it right. So f of x equals x plus 1 times x plus 23. Let's set this equal to 0. So x plus 1 times x plus 23 equals 0. And if x plus 1 times x plus 23 equals 0, then either x plus 1 equals 0 or x plus 23 equals 0 or both. And we could go ahead and solve these, or we could use the trick. Both of these x's have a coefficient of 1, so we know that our x-intercept, or our 0, is the opposite of this number. So I know I'm going to have my x-intercepts are going to be -1, because that's the opposite of +1, and -23, because that's the opposite of +23. But if you are not sure about that and you need to see the steps, all we're going to do here is solve these two one-step equations. In x plus 1 equals 0, I have to subtract 1 from both sides, and that's how I end up with x equals -1. And here, in x plus 23 equals 0, I would have to subtract 23 from both sides, and that's how I would end up with x equals -23. Now, sometimes we might get a third factor added into the mix. So we see here f of x equals 7 times x minus 13 times x plus 12. Let's go ahead and set this equation equal to 0. So 7 times x minus 13 times x plus 12 equals 0. And so again, if 7 times x minus 13 times x plus 12 equals 0, then one of these has to equal 0, at least one of these. Now, you might think that this introduction of this 7 here would change the way we do this, but it doesn't really. Why? Because we know 7 doesn't equal 0. 7 equals 7. So we're really just looking at x minus 13 and x plus 12. So if 7 times x minus 13 times x plus 12 equals 0, then we know 7 doesn't equal 0. So x minus 13 could equal 0, or x plus 12 could equal 0, or both. And again, since these x's have a coefficient of 1, I know that my x-intercept, or my 0, is just going to be the opposite of this number. So the opposite of -13 is +13. And here, the opposite of +12 is -12. All right, so in these examples, we're going to look at how we can use the distributive property in combination with the zero product property to solve these quadratic equations. So if I look at this first example here, it says 3x times x minus 4 plus 5 times x minus 4 equals 0. And what we notice is that both of these binomials are the same. They are both x minus 4. So what I can do with this is use the distributive property and rewrite this equation to look a little different. So I'm going to keep one of the x minus 4s. And what I'm going to do is I'm going to take the 3x and the plus 5, and I'm going to write them as a binomial here. So I end up with 3x plus 5 times x minus 4 equals 0. Now the reason why that works is because if I were to take this in FOIL, it would be exactly the same as this. Think about it. First, I would multiply 3x times x minus 4, which is what's happening here. Then I would multiply 5 times x minus 4, which is what's happening here. And then I would combine like terms, which is what's happening here when we add. So you could see that this form of this equation is the same as this form. Now, what's valuable about this? Well, now this is in factored form, and I can use the zero product property to find the x-intercepts or solutions for this quadratic equation. So again, if 3x plus 5 times x minus 4 equals 0, then either 3x plus 5 equals 0, or x minus 4 equals 0, or both. Now, one of these we already know the solution to. It's very easy. This x here is a coefficient of 1, so we know that the solution is going to be the opposite of -4, so we know x equals +4. But here on this equation, 3x plus 5 equals 0, we can't use that trick because our coefficient of x is not a 1. So this is actually a two-step equation, so we need to go ahead and work this out. So my first step here is to subtract 5 from both sides. And I end up with 3x equals negative 5. And then I have to divide both sides by 3. And so I get as my solution x equals negative 5/3. So these are my x-intercepts, or my solutions for this quadratic equation. X equals negative 5/3 and x equals 4. All right, let's take a look at this second example. And again, I encourage you to pause and try it on your own. We see we have negative 9 times x plus 2 plus 3x times x plus 2 equals 0. And we notice again, both of these binomials are x plus 2. So we can go ahead and rewrite this equation. We're going to keep one of the x plus 2's. And then we're going to write a new binomial, and we're going to combine this negative 9 and this 3x together. So now you could write negative 9 plus 3x. That's fine. But I like putting the x first. So I'm going to put the x first. So this is positive 3x. And this is a negative 9. So I end up with 3x minus 9 times x plus 2 equals 0. And we can go ahead and use the zero product property. So if 3x minus 9 times x plus 2 equals 0, then either 3x minus 9 equals 0, or x plus 2 equals 0, or both. And then we can go ahead and solve. This one we know, x plus 2 equals 0. This is a coefficient of 1 on the x, so we know that our solution is the opposite of positive 2. So we know we have x equals negative 2. Here, this is a two-step equation, so we need to go ahead and work it out. So I need to add 9 to both sides. And this gives me 3x equals 9. And then I need to divide both sides by 3. And I get x equals 3. So these are the solutions to this quadratic equation, are x equals 3 and x equals negative 2. All right, so a quadratic equation like this one could be a little tricky, because we see that we have this negative x times x minus 3 plus 6x minus 18 equals 0. So if we're looking for another x minus 3 so that we can rewrite this, well, we don't see it there. And the reason why we don't see it there is because here, 6x minus 18, what happened was the factor on the outside, like this negative x, actually got distributed. So what we can do is we can undo that by factoring, which means we can divide. So now how do we factor? Well, if we look at 6x and negative 18, what we could think of is we could think of greatest common factor. In other words, what's the largest number that we can divide 6x and negative 18 by? And the answer to that is 6. So if we divide both of these by 6, look at what happens. And the way we're going to do that, let me copy this down here, is since we're going to divide by 6, we're going to go ahead and put that out here outside the parentheses. And then let's divide. So what's 6x divided by 6? That's x. And what is negative 18 divided by 6? Well, that's negative 3. So now look what we have. We have negative x times x minus 3 plus 6 times x minus 3. And there we have our two binomials that are the same, x minus 3. And now we can go ahead and rewrite this equation using the distributive property. So we're going to keep one of the x minus 3's, and then we're going to write a new binomial here with negative x plus 6. So now we have negative x plus 6 times x minus 3 equals 0, and we can go ahead and finish finding the x-intercepts. So here, negative x plus 6 times x minus 3 equals 0. That means negative x plus 6 might equal 0, or x minus 3 might equal 0, or both. So we know that this x minus 3, again, since the coefficient of this x is a 1, we know it's just the opposite of negative 3, right? So we know on this side that x equals 3. Over here, the coefficient on this x is not a positive 1. So we need to go ahead and solve this. So we're going to subtract 6 from both sides here. And we get negative x equals negative 6. And now remember that this is a negative 1x, right? So to solve this, we now have to divide both sides by negative 1. And we get x equals positive 6. So here are the two solutions to this quadratic equation. X equals 6 and x equals 3. All right, so let's go ahead and apply this to real-world problems. It says here the height of one diver above the water during a dive can be modeled by the equation h equals negative 4 times 4t plus 5 times t minus 3, where h is the height in feet and t is time in seconds. Find the time it takes for the diver to reach the water. So in this case, think of the surface of the water as 0 when we're talking about height above the water. So we can take this equation h equals negative 4 times 4t plus 5 times t minus 3 and set it equal to 0. So that's going to look like this, negative 4 times 4t plus 5 times t minus 3 equals 0. And then we're going to go ahead and use the zero product property to solve this equation. So again, if negative 4 times 4t plus 5 times t minus 3 equals 0, then one of these must equal 0. Now we know it's not negative 4 because negative 4 equals negative 4. But maybe 4t plus 5 equals 0. Or t minus 3 could equal 0, or both. So let's go ahead and solve these equations. Again, here, this t minus 3, this is a coefficient of 1. So we know that t equals 3. And if you're still a little confused by that, if I solve this equation, t minus 3 equals 0, I'm just adding 3 to both sides, and I end up with t equals 3. Now on this side, 4t plus 5 equals 0. We're going to subtract 5 from both sides, and we get 4t equals negative 5. And then we're going to divide by 4. And we get t equals negative 5/4, or negative 1 and 1/4. So here we have two solutions, t equals negative 1 and 1/4, or t equals 3. Now the situation is, when you're dealing with real world problems, sometimes one of the solutions doesn't make sense. In this case, we are measuring the number of seconds it takes for a diver to reach the surface of the water. So can we measure time in negative units? And the answer is no. So the solution of t equals negative 1 and 1/4 does not make sense. That means the proper solution here is t equals 3. So how long does it take the diver to reach the water? Well, it takes 3 seconds. Okay, last example here, and I, of course, encourage you to pause and try this on your own and then come back and see if you were right. It says, the height of a golf ball after it has been hit from the top of a hill can be modeled by the equation h equals negative 8 times 2t minus 4 times t plus 1, where h is the height in feet and t is the time in seconds. How long is the ball in the air? So if you think about how long the ball is in the air, well, the ball is in the air until when? Until it hits the ground. And so since we're talking about the height, the ground is 0. So again, we can take this equation and set it equal to 0. So we say, okay, negative 8 times 2t minus 4 times t plus 1 equals 0. And then we go ahead and use the zero product property to solve. So if negative 8 times 2t minus 4 times t plus 1 equals 0, then one of these equals 0. We know it's not negative 8 because negative 8 equals negative 8. So maybe 2t minus 4 equals 0, or t plus 1 equals 0, or both. So we can go ahead and solve. So here, this is a coefficient of 1 on the t. So we know that it is the opposite of positive 1. So we know t equals negative 1. And here, this is a two-step equation, so we need to go ahead and follow the steps. So we're going to add 4 to both sides. We get 2t equals 4. And then we're going to divide by 2. And we get t equals 2. So we have two solutions, t equals 2 and t equals negative 1. And once again, in a real-world situation where we are measuring how long the ball is in the air, can we measure time in negative seconds? And the answer to that is no. So t equals negative 1 does not make sense in the context of this situation. So the solution is t equals 2. So how long is the ball in the air? The ball is in the air for 2 seconds.